Okie doke. This is problem 869. This is a 0.425 kilogram, 0.425 kilogram ball is traveling with some speed. There we go. This is 0.425, traveling with some speed 1.30 meters per second. It rolls across a level surface towards an open 0.327 kilogram box. So there's a box over here that's open. Okay, and it has a mass. This is mass of our ball, and this is mass of our box. I'm going to, X. I'm going to put X, right, because that's pretty distinguishing. I hope that's not confusing. I'll probably end up messing that up. It has a mass of 0.327 kilograms. Okay, and what happens is that the ball goes into the box, and then the box with the ball inside it slides across a distance. So this is what happens initially, and then the ball goes into the box, and then ball in box looks like this. We have our ball in our box, right? Here's our ball inside this box, and right, well, this has some initial momentum, and this has some mass and mass. So if it goes inside the box, then it's going to be moving along with some other velocity. Let's call this the BB, ball in box, right? And it's trucking along, and then it slides a certain distance. 0.520 meters, and then over here our box with our ball has a final velocity of 0. Right? It stops moving. So the question is, what is the coefficient of kinetic friction? That's awesome. Okay, so these are the kind of problems I just really like, probably because I'm a huge dork, but there's just like a lot of stuff going on, right? I mean, the neat thing though is that what's the coefficient of kinetic friction? Well, we can figure out how far this thing moves simply by knowing the mass of this and this velocity. Well, at least that's what we assume we can figure out, right? So how do we do that? Well, what is going to slow this thing down? Obviously, it's asking us for the coefficient of kinetic friction. So there's going to be some frictional force acting on this box once this ball and box are together. So it's going to have some velocity here moving to the right with some mass, where it's the sum of these two, right? The mass of the ball plus the mass of the box is going to be the mass of this thing, and it's moving along, and there's some force acting on it, right? There's a frictional force acting to the left that's slowing this down, and that's going to be equal to, how could we describe that frictional force, right? That frictional force is going to be equal to the coefficient of kinetic friction times the normal force of that box, which is going to be equal to its mass times its gravity, where the mass here is the mass of the ball plus the mass of the box, right, times gravity. Gosh, I make too many little mistakes. Okay, sorry, there's a little extra mark there. So the mass of the ball plus the mass of the box times gravity, right? This is just the normal force. So that would be the frictional force, and that acts over some distance, right? So there's work being done. Really, there's work being done. It's work by a non-conservative force. There's a frictional force that is doing some non-conservative work because there's a frictional force acting over some distance, and that's going to change the amount of energy in this box, right? This box is initially moving, and then it stops, right? So we could talk about the net work done on this box is going to be equal to its change in kinetic energy, right? We simply look at the work done here by this frictional force, and that should equal the change in kinetic energy from initial to final. And the final, we know something very specific about the kinetic energy there. We know the kinetic energy is 0. Well, we don't know exactly what the kinetic energy is at this point because we don't know anything about the velocity of the ball plus the box, right? How would we figure that out? Well, we do know something about the velocity of the ball up in this case, right? So if the ball moves into here and then goes into the box, and then the two of them move together. So that's, although it's physically not quite the same thing as some of the questions we talked about in class, it's there's a type of collision that describes describes that type of interaction, right? What do you think that is? An elastic collision? An inelastic collision? What do you think it is? This actually is a specific type, right? So I'm going to start the next video and you think about that, whether it's an elastic or inelastic collision.